Let's talk subtraction. Lisa's school is having a dance. All the tickets have been sold. The cheerleaders sold 2/5 of all the tickets. The basketball team sold 1/10 of all the tickets. How many more tickets did the cheerleaders sell than the basketball team? So what we're doing is we're comparing what the cheerleaders sold and the basketball team. And the cheerleaders clearly sold more, so they're going to be the top number. We're going to take 2/5 and we're going to subtract 1/10. Now, boys and girls, right now, if you notice, we have two different languages. So the question is, where's the common language between fifths and tenths? Now, if we skip count fives, 5, 10, 15, 20, oh, what did we say? We said 10. So our common language, boys and girls, our common language is going to be tenths. Tenths and tenths. Now, we already know what this one is, right? It's going to be 1/10 because we're already there. Now, what did I do to 5 to get to 10? Well, I times it by 2. Whatever I do to the bottom, I'm going to do to the top. What's 2 times 2? Well, that's 4. Now, do we have tenths? Tenths? Yep. Are we ready to subtract? Yeah. 4 less 1 is 3/10. So, the cheerleaders sold 3/10 more tickets than the basketball team. Well, let's look at some more problems here. We've got two thirds, and I'm automatically going to put these vertically, okay, just because it's going to help us vertically. And I probably should have done the addition problems vertically, but especially with subtraction, I want you to think about these vertically. So we have 2/3 less 2/6. Now, first off, we've got to notice thirds and sixths, they're not the same. Okay? The vast majority of the world can see that 3 and 6 are not the same, correct? Question is, where are they going to meet? Well, I can start skip counting. 3, 6, 9, whoa, 6. I said that right here. So they're going to meet, ladies and gentlemen, somewhere in the sixth land. Now, I can look at 2/6. This is already in the language we need. So now we have to put this one in we have to put our top number in the language we need. And we figure out, what did we do to 3 to get to 6? Well, hopefully you realize you times it by 2. Whatever I do to the bottom, I do to the top. So I have 2 times 2, which is 4. Now we have 4/6 minus, and we can just repeat putting that there, 2/6. Are we ready? Are we ready to subtract? I think we are. Our language isn't going to be the same. Our language is going to be 6. But now we've got 4 less 2, which is 2. Now, and depending upon the problem, boys and girls, you might have to reduce this. I mean, what goes into both 2 and 6? And hopefully you realize, well, 2 and 6 are even numbers, so they are both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So 2/6 is the same as 1/3. We'll give you one more problem as a example, and then it'll be time to work on your own. Let's give you one a little bit more difficult. 9/12 less 2/8. Okay, so this problem, and I'm going to erase this just because it gives me more room. I need more room. All right, 9/12 and 2/8. The question is, where do 8 and 12 meet? Now, we can do this one of several ways, and I'm going to show you another way that you can do this. And I'm just going to do this down at the bottom because I'm going to erase it when I'm done. I'm going to start counting by 8s. 8, 16, 24, 32, 40, 48. I think that should be enough. Now I'm going to skip count by 12s. 12, 24, 36, 48. Now, what we've done, boys and girls, is we've listed the multiples of 8 and we've listed the multiples of 12. And what we're looking for, boys and girls, is we're looking for the numbers that are the same in each. Well, 24 and 48. So where 8 and 12 are going to meet are 24. So I'm going to just slide that over to 24, because they're the common 24. And this, what we just did, boys and girls, this is called the LCM, or the lowest common multiple. So now that we have our lowest common multiple, I'm going to erase all this because it's just extra right now. Now that we have the LCM, what we're going to do is we're going to figure out what did I do to each of these numbers to get the LCM. What did I do to 12 to get to 24? Well, I times it by 2. Whatever I do to the bottom, I do to the top, and 9 times 2 is 18. What I do to 8 to get to 24? Well, I times it by 3. Whatever I do to the bottom, I do to the top, times 3 is going to be 6. Now, boys and girls, I am ready to subtract. First off, I'm just going to transfer my language down because we're not going to change our language right now. And now we're ready for the math. 18 less 6 is going to be 12. Now, hopefully you see this right away, boys and girls, but this answer can be simplified. I can put 6 in there, I can put 4, I can put 3, but in this case, I know that 12 and 24 are both divisible by 12. If I take 12 divided by 12, I'm going to get 1, and 24 divided by 12, I'm going to get 2. So this right here is our simplified version of it, and then this is our unsimplified. Alright, so 2 problems for you to work out on your own and check and see how you did. We have 4 fourths less 5/8. And then your second problem is 3 fifths less 3 sevenths. Okay, so pause the video, solve them, and then check and see how you did by restarting the video when you're done. Good luck. Alright, 5th graders, first thing we have to do with this problem is we have to make sure they're talking the same language. 4 and 8 are not the same language, but they do meet, because if I skip count by 4, 4, 8, we know that they are going to meet at 8s. And this is going to, now, because the bottom one's already an 8, we don't have to change that, so it's going to be 5, but then I have to look at 4, and what did I do to 4 to get to 8? Times 2. Whatever I do to the bottom, I'm going to do the top. 4 times 2 is 8. Now we have the same language. 8's 8's. We're ready to subtract. Our denominator is going to stay the same. 8, 8. And when we subtract 8 minus 5, it's going to give us 3. So the answer should be 3/8. Okay? Now, boys and girls, one of the things, I try not to make my fraction line diagonal like that. Hopefully you're making them so it's a straight horizontal line. But because I ran out of space, I can't do that. Sorry. Okay, now we have 3 fifths and 3 sevenths. Not at all the same language. We have to figure out where they're going to meet. Once again, I'm just going to go 5, 10, 15, 20, 25, 30, 35, 40, 45. Now, hopefully we'll find something. 7, 14, 21, 28, 35. Hey, wait. We have 35. 35. That's our LCM, and that's the language we're going to talk in. 35ths. Whoop. 35ths. Whoop. Now, what did I do to the 7 to get to 35? Well, I multiplied it by 5. Whatever I do to the bottom, I do to the top. 3 times 5 is 15. What I do to 5 to get to 35, I multiplied it by 7. Whatever I do to the bottom, I do to the top. 21. 3 times 7 is 21. And now I'm ready to subtract. 21 less 15. 15, 16, 17, 18, 19, 20, 21. I'm looking at my fingers. I had 6. And my language is 35. All right, so we cannot simplify this anymore because 6 is divisible by 2, 1, 2, 3, and 6. 35 is not divisible by 2 because it's an odd number. It is not divisible by 3, and it is not divisible by 6. So that's how it's going to stay. All right, so that's the end. That's adding and subtracting fractions with unlike denominators. If you have any questions, please talk to Mr. Winkleman. He's here to help you understand this more. We went through a lot today, okay? Your homework is going to be practicing this. You're going to have a quiz so I know who's understanding it. But if you have questions, this is your time and this is what you need to do. You need to ask Mr. Winkleman to help you clarify. All right, that's all I got. Come see Mr. Winkleman, get your wonderful parting gift, and yeah, good work.